in order for us to fully understand why integration works, we need to understand the fundamental theorem of calculus 1 and 2. But in order for us to understand those two theorems, we need to understand all of these. And in the previous video, we've already seen the mean value theorem. In this video, we're going to look at this. And in general, all of these are easy to grasp. This one here is a nightmare to understand. Okay, so let's look at this one here, Rolle's theorem. So with Rolle's theorem, this is the textbook's explanation. This is the textbook's explanation. So let me just give you an overview of what's going on here. So if you have f of a equals f of b, so no matter what function you give me, let's just make up a function. Let's just make up a function like this. So this is our function, our random function, f of a. When you put this into here, it will jump to a height of f of a. So this has a height of f of a. And then when you put b into here, it will jump to the same height, f of b. So when I say if f of a equals f of b, it means that they're of the same height. So let's just imagine this has a height of 7. They both have a height of 7. So if you have a function where the two heights are the same, it implies that there exists at least one c where the gradient equals 0. So in our case, the gradient equals 0 is right here. There must be a c somewhere in between a and b where the gradient is 0, where the gradient where the function is flat, where the gradient is 0. So hang on, let me give you another one. Let's look at this. Let's look at this function here. You see, no matter what function you give me, as long as it's continuous and differentiable, somewhere in between a and b, there must exist a c where the gradient, because it's f prime, equals 0. So in this case, the gradient is 0 right here. So here, the gradient is flat. The gradient is 0. You can try and break down the theorem. So for example, let me give you this random function here. Okay, you can try and break this down by saying, well, I'm going to create a function. Well, I'm going to look at f prime. I'm going to create an f prime where the gradient is never 0. So let's look at this one here. You see this function here, I'm always going uphill, 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 meaning that the gradient is never 0 because I'm always going uphill. But in order for me to end at f of b, in order for me to end at this point here, I need to turn around because I can't keep going up all the time because I'm trying to create a gradient where it's never 0. I'm trying to break down this thing here, but I can't, because in order for me to end up at f of b, I need to turn around. I need to turn around in order to end up at b. But then the minute I turn around, there's a point c where the gradient will be 0. It's 0 right here. So you can't break this theorem down. Suppose you have a function like this. Hang on. Suppose you have a function like this. Well, I'm going to try and break it down by going uphill all the time. Why? Well, you got a gradient here. Let's just say the steepest point here is, let's say the steepest is, it has a gradient of, let's just imagine the gradient of 2 here. This has a gradient, hang on, this has a gradient of 2. So I'm going to try and break down the theorem by going uphill at a steepness of 3, which means it's really, really steep. So it's never going to be 0. The gradient will never be 0, but in order for me to end up at f of b, I need to turn around. But then the minute that I turn around, there's going to be somewhere where the gradient is 0. So you can't really break down this theorem. You could try and say this. Well, I'm going to create a gradient that's a horizontal line. Sorry, I'm going to create a function that's a horizontal line. But then there exists a c here where the gradient is 0, because here the gradient is 0, it's flat. Here the gradient is 0. So here all the c's are always 0. So there must exist at least one c. You can't break down this theorem, and if you don't understand what this is talking about, try and create yourself a function. I don't care what function you create, but there will always exist a c somewhere in between the two. Oops, that didn't end up here. There will always exist a c somewhere in between where the gradient is 0. Remember, you have to start here and you have to end here. If you don't understand this, try and create a function where there will never be a gradient of 0. It just can't be done. The minute you turn around to go up here, there will be a gradient of 0. Okay.